For this video, let's try to evaluate the integral of sine z dz from 0 to I. Take note, we are on trigonometric functions now, and as soon as we try to use later on one of its limits, the upper limit, which is I, we are going to introduce the other type of function, which is hyperbolic. I'm talking about this process here, the integral of your sine z dz from 0 to I. Of course, we're going to use the same process of integrating, or the rules of integrating trigonometric functions. Let's not forget that the integral of sine z dz is equal to negative of cosine z. Okay, this is also true for the context of real numbers, and this is also true for the complex numbers here. So basically, applying that, this is equivalent to the negative of cosine z, but to be evaluated from 0 to I. Now, as soon as we try using the limits, you have here negative of cosine of your I minus, take note of that, negative of cosine of 0. Please don't forget the grouping symbols. Now, for this is equivalent to negative of cosine I plus cosine of 0, which is equal to 1. So you have here negative of cosine I plus 1. Now, since the first term has imaginary unit I, simply following the rules of writing complex numbers, this is equivalent to 1 minus cosine I. Earlier, I mentioned that once you will have imaginary unit I as part of your angle for your trigonometric functions, this would introduce the idea of hyperbolic functions. In one of our playlists for complex numbers, specifically for types of functions, we're able to understand or discuss that the equivalent of cosine iz, that's iz, cosine of iz is equal to the hyperbolic function of cosine z. Okay, the hyperbolic function of cosine z. Okay, we have that already. We have proven that as well. So please try to review those videos. Now, this z here is the coefficient for your I. That would be your angle here for hyperbolic function. But since here, our cosine I, okay, its numerical coefficient is of course 1, we can rewrite this further, introducing hyperbolic function 1 minus the hyperbolic function of your cosine of your numerical coefficient 1. This is also another form of the result of this item, introducing hyperbolic function, or you could also stick to this if you would like only cosine I. But nevertheless, they are of the same result. Thank you very much for watching.